Okay, so we are going to be working in your booklet on page 53. If this year, that may subject to change for later years if I use this video, but this year it is page 53 in your yellow booklet. And so all we're going to be doing is indicating the number of ions that we see. So we're just going to be doing a counting of atoms, or if you want to think of it as ions, either way. So when I look at this, I have one carbon. Oh, I guess I'm supposed to be doing evens. So, but I'll start you off here. One carbon, and I have two oxygens. Okay, 1, 2. Now be careful. This here is called the coefficient, the number out in front, the coefficient, just like in math. And what that means, even in chemistry as it does in math, it really means that I have two of these. So I could take that 2 off if I wanted to. This is what it looks like. It's saying I have 2 of those. So when I go to count my sodium, I see 2 there and then 2 in this one. I have 4. My sulfurs, 1 and 1. And my oxygens, 4 and 4. Now, it actually asked over here, so according to how it asked, this actually asks for how many SO4s do you have, so it's not breaking it apart. So I have 1 here and 1 there. I have 2 of those. So just be careful how it asks for it. Okay, now let me back up to that one again, and let's talk about it shortcut, because I know you're not going to want to write that out every time. And so this is again, distributive property that we're doing. So this says I have 2 sodiums and I have 2 out here. That makes the 4. Okay, and then because there's no parentheses here, we just have 1 of those. That's understood. Again, since there's a 2 out in front, 2 times 1 gives me 2 of those. Okay, I'll skip number 3. I'll let you do that. So this one says that, now I'm going to leave the ammoniums together and the phosphates together, so I'm not separating them. So first I'm going to look at this one. That's my ammonium. There's a 3 out here, which means already I had to have 3 to balance the the compound, but there's a 5 out here. So again, distributive property, 5 times 3, 15. Okay. My PO4, very similar to what I did up here, there's no parentheses, there's no subscript, so it's an understood 1. So 5 times 1 would be 5. So I would have 15 ammoniums and 5 phosphates here. Here's this one. Now this one doesn't have any parentheses whatsoever. Okay. So it tells me it wants me to do the ammoniums and the acetates. So here's the ammoniums. There's the acetates. There's no parentheses, so both of these are understood to just have 1. But there's a 3 out in front, coefficient. So 3 times 1, 3 times 1. That's what I have. Okay. So if I didn't have the 3 out there, I would have just had 1 of each one of them. 8. This says I have 3 hydrogens, but there's a 2 out in front. So that means I have 6 hydrogens. Now this one, if you look, it broke apart the phosphorus and the oxygen. So I'm going to look at each one separate. If you need to put a little 1 down here, like what I was doing up on those, you can. So this says I have 1 phosphorus right here, but there's a 2 out in front. So that means I have 2 of them. 4 oxygens, I have a 2 out in front. That gives me 8. And the last one here, I need boron, and then I need the nitrate. So the nitrate, this is going to be left together. So here's boron. There's no subscript, so that's understood to be a 1. There's a 4 out in front. Don't forget that 4. So 4 times 1 means I have 4 borons. 4 times 3, 3 nitrates here. There's a 4 out in front. Means I have 12 nitrates. Okay, and that's how what we call counting atoms or counting ions. Okay, charged atoms or ions. So you need to back up and do problems of the odds on this assignment.